Good morning, good afternoon, good evening, wherever you are in the world. Welcome to LunchBytes. Thank you for joining us today. We're going to jump straight into the content today, but before we do that, we just want to set out a few expectations for everyone who's joining us live. So please make sure that you're aware of others, that you're being welcoming and respectful and understanding of differences. Please be friendly and patient, be open to all questions and viewpoints, and importantly, be kind and considerate to others. This show is going out live and it's supporting accessibility features. So today's show is available with live captions on Learn TV and YouTube. So please use the selector below the video if you require closed captions. And captions are also available on demand if you're watching this back. So please do utilize that if you need it. What is LunchBytes? Well, LunchBytes is a show that's been airing every 2 weeks for almost a year now. It's a fortnightly tech show. We're joined by Asta, myself, and usually Annika and Steph. And we're also joined by a range of technical experts from across the UK to help answer sort of our top questions about Azure. So if you do have any Azure-related questions or problems, or you want to learn more around Azure, then please do drop us a message. You can contact us at lunchbytes@microsoft.com, or please feel free to leave a comment under the video live stream today. So a quick introduction to myself. My name is Tyg Brennan. I'm one of the co-hosts on LunchBytes. I'm a cloud solution architect in the UK, and the area that I focus on is app innovation. So this is all things from kind of the developer side of things, so starting with GitHub and Azure DevOps, all the way to how you look to integrate some of your solutions. So maybe using Logic Apps, API development, and how you want to host your applications as well. I cover all those sorts of areas as a cloud solution architect. And today I'm joined by my colleague, Asta. Asta, do you want to give a few words to introduce yourself?
Hi everyone, so my name's Asta, and like Tyg, I'm also a cloud solution architect within digital and app innovation. So I focus more on Power Platform, so things such as Power Apps, Power Automate, that kind of technology. And yeah, great to be here.
Brilliant. Great to have you, Asta. And as we jump into today's content, I'll quickly say also you can contact us on GitHub as well. So we've both got our GitHub links underneath our job titles there as well. So today's content is going to be all around GraphQL on Azure. So Dave, I've just brought you up on our live stream, and we're going to be doing this together. It's going to be a bit of a co-presentation on this one. Do you want to give everyone a quick introduction to yourself before we jump into the content?
Sure, yeah. Hi, good afternoon, everybody. So yeah, I'm Dave. I'm also a cloud solution architect based out of the UK. I've been at Microsoft for just over 6 years now, and just like Tyg, I focus on app innovation as well, and specifically I focus on areas to do with APIs, integration, and when we look at Azure, that really is talking about services like Logic Apps, API management, functions, service bus, that kind of thing. So yeah, really excited to be here today.
Yeah, all the fun serverless technologies, definitely. Okay, so we're actually going to jump into the technical content, but as we do that, as this is a live show, it's important that we get your feedback and your questions on this as well. So please do feel free to drop your questions below. We will have a dedicated time towards the end of the session to cover those questions in a Q&A session, and Asta will make sure that your questions get answered on the call today. Retrospectively as well, when you're watching this back, please feel free to leave questions as well, and we'll hopefully get back to you on YouTube or Twitch as well. So a little bit about the agenda of today's session. We're talking about GraphQL on Azure. So we're going to start with a little bit of the history of APIs. We're going to touch on different types of APIs that have been involved. So we've got SOAP and REST, and then we're going to introduce some of the basics of GraphQL as well, and how you can create a GraphQL server, and then how you manage that with the likes of API management. So that's the general structure for today's session. So if we first touch on the history of APIs and how they've been developed, it kind of starts a lot with SOAP APIs in the late 90s, but the real sort of transformation in terms of modern API use is really around the year 2000, when Roy Fielding wrote a dissertation on REST and RESTful APIs. And so it started out in around 2002, 2004, where we started to see an initial usage of APIs. And then 2006, there was the likes of Facebook, Twitter, who all started to implement APIs for ways for users to interact with their data, and offering, for example, user profile information. If you want to go retrieve that, then you can do that. You've got the likes of Flickr creating photos, platform sharing kind of system. Well, how do you interact with that? Well, you can use APIs, and APIs stand for Application Programming Interface. So it's a way for you as a user to interact with an app. So after sort of like the initial boom in usage of like Facebook, Twitter API in around 2006, we really started to see APIs being used in e-commerce and interconnectivity of all your applications. It became really popular. And up to the point around 2012, GraphQL didn't exist. And GraphQL came into existence pretty much through Facebook. And Facebook open sourced it in 2015. And so GraphQL will be the main topic of today's session. And as people started to use APIs and really get a handle of them and the power of APIs within their apps, the question around security started to pop up, particularly in 2018, when you had the likes of this Facebook API that I've mentioned already. You could get user information. Well, that was exactly what was used by Cambridge Analytica, for example, to get information about other people and political voting and things like that. So security came into question around 2018, and that's been a hot topic since. And a very important area of API development is how do you ensure that your APIs are exposed correctly and people can only get the information that they need. So we'll jump on into the first type of API in terms of SOAPs. So SOAP stands for Simple Object Access Protocol. It does use things like HTTP as a protocol, but it can also use SMTP, TCP, and UDP. So different formats and ways that you can get your messages to talk over different protocols. It's an XML-based API. And so the XML you can see on screen is the example and the blue sort of code. And Dave, did you want to touch on a few of the other things around SOAP and its usage and the power of SOAP?
Yeah, I mean, as Tyke said, SOAP has been around for a long time, and I can remember using it back in the 90s. And it originally came as a protocol that was defined by Microsoft as a way of moving away from COM and DCOM, and they've been around for a long time, but were incredibly rigid in their structure, way more than SOAP ever was. And there was a need for more distributed and more flexible sharing of information between different consumers and partners, and that's kind of where SOAP came from. But it does have this, as is on the screen here, this very rigid structure where you can't just pass a payload. It has to be wrapped in a SOAP body, and that is wrapped in a SOAP envelope. And then there are SOAP actions that need to be understood, and there are different ways that you can configure that. And all of this is really adding to additional processing that the client and the server both need to do. And those that remember things like you have a WSDL that defines that whole service, and the schema that's defined in there becomes a contract. And if that contract changes, then often that could be considered as a breaking change, which would then break that communication between the client and the server. And there really wasn't much in the way of flexibility for adding additional data or taking data away. And this is really not suited to the way that we build systems today. When we think of what modern architectures are today, and Tyg will go and talk some more about that now with REST.
Yes, that's a good thing to touch on now. So REST developed in a slightly different way. So REST stands for Representational State Transfer. And it's essentially a way that you have a client who is sending a request, and then you have a server that's dealing with that request. And it uses HTTP methods like GET, POST, PUT, and DELETE to interact with that server. But importantly, and this is where it's going to differentiate with GraphQL when we touch on this a little bit later, is that pretty much the server provides the information about the current state of the resource. The client doesn't really have much say in this. The client sends a request and the server decides what they're going to respond back. And this will be slightly different with GraphQL when we touch on that a bit later. REST does require HTTP, and it's in a JSON format, so JavaScript object notation. And it can be other formats, but it's JSON format predominantly. And so it does provide a bit more flexibility when you compare looking at JSON to XML in the very different sort of scenarios. And see, Dave's just jumped up to go check on something. You all good, Dave?
Yeah, good.
Nice. Is there anything that you wanted to touch on in terms of REST before we move on?
I think only that it's the flexibility that is the key thing here, and the fact that these days JSON has become the predominant format for exchanging information between different systems, and that really suits well with REST. But yeah, that was a good description.
We'll jump on and start to introduce the basics of GraphQL. And I can see that it's already had a few comments coming through. So Ozbobwa and Fuel Stable will definitely get to your questions as we get later on, and some good questions as well. And yeah, Dave, you do look like a bit of a ghost as one of the comments so far, but it is what it is.
Yeah, I've got a window behind me. I've tried closing curtains, open curtains, it's just not making a difference.
Yeah, no problem. Okay, so the basics around GraphQL resolve around mutations, types, queries, and resolvers. So I'll jump in and introduce the idea of a type within GraphQL. So a type is essentially you're defining an object on which you allow queries. So if you look at the right side of the screen right now, we've got a type of student, and this student is going to be our object, and they're going to have fields within that. So we've got an ID, which is called ID, and the exclamation mark at the end means it's non-null. And then we've got a first name and last name, and both of these we specified as strings. So essentially with a type, you define the fields that are in your object. Types can also be hierarchical. Dave, do you want to touch a bit about how that hierarchy sort of works with types and the importance of that?
Yeah, sure. So the important thing here is that the client is able to specify the data that it wants. So when we think of defining types in a schema, then as Tiger's got here, we've got a student type, but that student is likely to be part of some other kind of hierarchy. And taking the education example, they'll be part of a class, the class will be part of a school, there will be exam results, there'll be all kinds of relationships that exist for that student. So when defining these types, we can define this hierarchy in our schema, and it's that schema that the client is then going to be able to look at and then decide the data that the client wants. And they can do that throughout that hierarchy. They can specify different types at the same time. So for example, they could pull back a specific student, but maybe all of the classes in that school, and it's the client that's defining the data that it wants, and it does that through these GraphQL types that Tig is talking about.
Yeah. So evolving on top of types, how do you get data about those types that you've got? That's where you implement queries. So queries are the way for you to interact with your objects that you've defined. So you can consider it like a standard operation. And so on the right side of the screen again, we've got at the top, we've got three different queries. So we've got the type query with greeting, students, student by ID. So if you look at the students query, this returns an array of the type student. So this will give us the list of all of our students if we applied that query. And this is a way for us to interact with that data and get things back. So you can pass through parameters as well of your queries. So when we're looking at a query of student by ID, we're passing within the brackets, we've got ID, and we have to field that ID field. And then it's going to return us the student type as the response. So if we provided ID1 returned John Smith as a student, then that would be how the query works with that. Now, when you've got a query, how do you actually respond that data to the client? Well, this is where your resolvers come in. And so a resolver is essentially a query handler. And you can have many different resolvers within your GraphQL schema, within the API in general. And you can write it in your language of choice. So we've written some in JavaScript, there's .NET resolvers, loads of different types of resolvers that you can use. And in this scenario, on the right, on the second line, we've defined our query. And then there is a greeting. And we return hello from in this example is from tutorials point. And so this is our resolver, and it's just returning the string. Now, if you wanted to pass through more arguments, more fields, then you can do that. And you can connect up to databases. So if you've got, like I've seen in one of the comments, you've got maybe a SQL DB, then maybe your resolver will then do a SQL select statement and get the data that it specifically wants using the IDs and the fields that you've entered within your query. Dave, is there anything you want to touch on the resolver side of things?
Yeah, I guess the key thing to think about here is that the resolver is responsible for fetching the data. So when we look at the type system that we looked at on the previous slide, where we had maybe a hierarchy, then you could have different resolvers at different levels. So you could have one resolver, for example, that goes to fetch the student data, and that may come from a database. You may have another resolver that would go and pull back the detail about classes. Now, that could be in the same database, and it could just be issued as it or implemented as a join. But what if that data is actually elsewhere? What if that was in a different database or even in another API? And that's where these resolvers become incredibly powerful, because the GraphQL runtime is able to look at the different types and say, okay, I need to figure out where this data is going to come from. There's a resolver that's been defined, and then it goes off and fetches that data from that particular data store or API.
Yeah, exactly. Well said. So the last thing we want to touch on is the mutations side of things. So mutations are very similar to queries in the fact that you're interacting with some form of data at the back end. And the difference with mutation is that you're kind of editing the data with mutation. It's the way that if your query is just retrieving, mutation is you making changes to the data, inserting, making other changes. Consider it like a post request almost, in terms of REST and how you interact with something and provide a backend with data. Dave, is there anything on mutations you want to cover?
No, I think that's good.
Okay, so we want to jump into a very quick example and show you kind of the difference of where GraphQL is used compared to REST. And this is a great slide that was delivered in one of the Azure Fridays from Scott Hanselman and Elizabeth Barnett. And so this is showing the Microsoft Store. And within the Microsoft Store, you've got many different components within it. So you might have the best entertainment apps, the most popular utility apps that you can see on screen. Well, how do you get that data? Well, typically with REST API calls, it's a GET request on the GET categories. You got to get icons. The point is that there's loads of different requests that you end up having to make to all these different endpoints. Now, GraphQL, one of the real advantages is that we pretty much condense that down to one endpoint that you're going to have to call. And I'll show you that here. So here you can make one query to the Microsoft Store. And if you want to get the categories and you want to get the apps and you want to get the name, rating, image, you can put that all within one query and list exactly what you want. So in this scenario, the GraphQL query is doing get apps, and within the utility category, so at the bottom, we only want the name, the rating, the image, and the price. If we were using a REST API scenario, then we might have to specify the REST endpoint that is only to do with price. We might have to specify the ratings. But if we were just specifying, for example, just the apps in general, we as a client have no control over what the server is going to respond back. So the server could send back loads more information that we require or need. Whereas GraphQL, we request everything that we want. So you can develop really fast front-end clients using GraphQL. That's one of the really good advantages of this kind of scenario and an example. Just a typical like e-commerce store front end, it can be developed just with one GraphQL endpoint. And that's the way that you can call it in this scenario. Dave, is there anything you want to touch on here?
No, I think other than just as we said earlier, that the point here is that the client is able to specify the data that it wants rather than having to go and fetch some data, return that data, then go and fetch some more data, maybe to a different REST API, I think, as you just said. And the other point I just wanted to touch on the mutations, that we didn't talk about is around subscriptions. So mutations are around when things get updated, or created, but you can actually, as a client, subscribe to those changes so that you can be notified when those changes happen.
Exactly. So actually, we're going to talk a little bit about the advantages. So Dave, do you want to carry on and tell everyone about some of those advantages of GraphQL?
Yeah, we've touched on some of these already. That the client is able to specify the data that it wants, and that also, it kind of implies that any changes to the back end is not going to affect the client. So if the client says, I want some student details, I want their name, I want their full name, surname, and maybe some address details, if that API then goes and adds a load of additional data to that response, that's not going to affect the client. So the client only gets the data that it needs. And with today's modern applications and apps, etc., being able to pull back the data that you want is really, really important, especially if it's a mobile device and it's on the go somewhere using mobile connectivity. Then you don't want to be pulling back any more data than you actually need. And from a developer point of view, that's great as well, because they have a schema. They look at the schema, they define the data that they want, and they can then pull that back. They don't have this fairly complicated hierarchy of REST APIs and operations that they need to navigate. And we've all done it. We've called a REST API to pull something back in order to get some kind of ID or name or something, to go and make a further call back to another REST API to go and fetch some more data. And it just adds to what becomes a really chatty type of interface. And of course, as we have these resolvers that we were talking about earlier that operate down at the field level, then we can also apply security at that level as well. So with a REST API, you would typically have security at the operation level, or maybe at the API, but typically at the operation. Whereas GraphQL treats this slightly differently, without thinking about it in terms of operations, but in terms of the data itself. So being able to apply security in that way also offers a lot of flexibility.
And on the disadvantages side, what's it looking like with GraphQL?
Yeah, so I think some of that flexibility comes at a price. So the queries that get created can get quite complex, and we have to be a bit careful here, because there are some kind of attacks that attackers can use in order to force the GraphQL server to be creating some really quite complex queries that are going to take a long time to complete, or in some cases not complete at all. And so we need to be quite careful about that structure, and following on from that, keeping that structure as simple as you possibly can in terms of the GraphQL types that we're defining in that schema. Because at the end of the day, things need to be easy for that client to understand. So having some kind of really quite complex structure, like you might have in a SQL database with lots and lots of relationships, is just going to get quite complex for the client to understand.
Yeah, completely agree on those points. So in terms of GraphQL, once you create something, then how can you host it? Well, API management has got the built-in option to host GraphQL and synthetic GraphQL, and we'll touch on what the difference is. So API management is one of the services within Azure. It's how you can import in some of your APIs or expose them through a single endpoint, like an API management endpoint, and then provide additional value to your APIs by applying things like policies and allowing transformations to occur onto your APIs, adding in security, things like that. That's what API management is used for. So in the past, you can, and even obviously currently, you can import things like logic apps as an API. You can import app services and functions as API, or provide typically like an open API specification. If it was SOAP, then it might be something like a WSDL. You can provide those schemas and specifications and import your APIs. But with GraphQL, there's two options that we wanted to touch on. And Dave, do you want to talk us through what is, I guess, GraphQL pass-through with API management?
Yeah, so if you have an existing GraphQL server, and that could be hosted anywhere, you've defined your schema, and that GraphQL as a server exists in its own right. But what you might want to do is to expose that publicly, or maybe you want to apply some other controls around it, and that's where pass-through in API management comes in. We'll demo this in a second, but you can import the schema directly into API management, and that would then create a GraphQL endpoint in API management. And as the queries come through from the client, or the mutations, they would then get passed straight through to the back end. And you might think, why would you want to do this? And it's for the reasons that Tig was touching on, that API management is a service that is hosted in Azure that provides a whole load of features around security and governance and API lifecycle out of the box. So by fronting your GraphQL endpoint with API management, that's going to give you a whole lot of control. And it also means that the clients who are consuming APIs for your organization, they may be consuming GraphQL APIs, they may be consuming REST APIs or SOAP, but all of those are going to be exposed through the same mechanism within API management.
Yeah. So pre-existing scenarios, then pass-through is a great way to get started and just try out things. What about synthetic GraphQL, Dave?
Yeah, so synthetic, I think it's a really cool feature of API management, because what this lets you do is to create your own GraphQL endpoint in API management, but the backend may not necessarily exist as a GraphQL endpoint server. It might not. So think of cases where you have backend APIs that could be REST or SOAP, they could be on premises, they could be in the cloud or somebody else's cloud. And what you want to do is to be able to configure those to be surfaced up through a single graph. And that's what synthetic GraphQL does. And with that feature we spoke about earlier, called resolvers, then we can define our schema inside API management or outside, but we can create it, import it into APIM, and then through resolvers for the different types, we can go and point at different endpoints. And Tig has got a few here, like a logic app or a function, but like I said, it could be anything else. But it can also be another GraphQL server. So what you might want to do is to take an existing GraphQL server and augment it with additional information, maybe an additional or type or some other information you want to get from another REST API. And with API management, that's dead easy to do, and we'll demo that later.
Yeah. So there's different ways that you can host the GraphQL server as well. So in the couple of demos that you're going to see from us in a moment, we use Azure Functions, but you can certainly run GraphQL server on app service, because you've got things like Hot Chocolate or Apollo server as GraphQL servers that you might want to run. And it just depends on what kind of languages you want to use in terms of what framework you would utilize. You can also use Azure Kubernetes service if you want to containerize your server. And same thing, Azure Container Apps. So this is like a managed kind of Kubernetes service, in the sense that there's Kubernetes running under the hood, but all you need to provide is a container image, and you can run that. So think app service, but for AKS. And that's kind of the summary of how Container Apps sort of works. So there's different ways that you could host the server. I think let's jump straight into demoing. And for everyone watching live, the rest of the presentation is all around demos. So I'm going to jump in and showcase some demos in a moment. So I'm going to go ahead and share my screen. Okay. And then Dave in the background as well, if you want to share your screen, and I'll get to that later. So what I'm showing right now is my Visual Studio Code. So if I've imported a repo that I've got, and this repo is all around a JavaScript-based Azure function, and it's hosting Apollo server. So I think my smart...
Wonder what that was.
There we go. That's on mute now. That's the benefits of always doing these things live. Okay, so I've got my GraphQL server that's an Azure function. So here on the side, I've got my function.js, and it's actually a TypeScript function. So here we talked earlier around resolvers, and this is where my resolver is. It's a resolver that when a query of hello is provided, we just respond with hello from our GraphQL backend. And this, using GQL, is how I specified the schema. So I've got a type of this query, and it's just hello string, and it's going to respond to string, and that's the string that it's going to respond. We're using Apollo server, and so I'm going to run this locally. So I'm going to do npm start, and this will start running our Azure function locally within VS Code. So it might take a few moments. And we'll let it load up. And what we're going to do here is we're going to essentially get our own server on our local host once the function is up and running, and we're going to interact with that. And I'm going to show how you can make a change locally, and then that change be represented within your Azure function as well. Okay, there we go. Again, func start, and things are starting to come through. Yeah, and good point, Joseph. I'll put the demo on full screen there as well for you. Okay, so we've got our local host right here, and this is our GraphQL server. So I'm going to jump over to this, and this is it. So I'll refresh. This is using the Apollo Studio for looking at GraphQL. Okay, and so we've defined our server, our sandbox as our local host. And then if I run that query, we get hello from our GraphQL backend. And then if I want to do something like make a change, and so I might terminate my function right now and put LunchBytes from our GraphQL backend, and then I npm start this and get it running again. The idea is that we will see that change occur when we recall it. So in the meantime, whilst that function is going up and running, I want to show you that once you've got a function, and I can process the steps here, you might go, for example, right-click on GraphQL and do deploy to a function app. So here you can then choose the function apps, and that one will load up, and I can select that. So this scenario, I'm not doing that right now. I'm just loading up my local function with the change that I've made that's being represented. And I'll show you what the function looks like in Azure in the meantime. So here's my GraphQL server Azure function. And we can jump to the function over here. And here it is. And you jump to your graph, and we've got our function, and that's all it is. The simple bindings that we've got in place, and it's running our Apollo server. So if I jump back to VS Code, and we're up and running again, so I can go back, and if we run another query, we've got a different response. We've got hello LunchBytes from our GraphQL backend. So I'm showing that we can develop locally on our VS Code in our JavaScript TypeScript function. And this is using Node 12 at the moment and Apollo server. And if you do a query like hello, then we get our hello LunchBytes from our GraphQL. And then you can then go and implement that within Azure. And I can showcase that actually what I've got here now is my GraphQL server that's sitting in my Azure function. And I can send a request, and I'm getting my response back. Hello from our GraphQL backend, the one that earlier I'd posted in. And so, Dave, I'm going to jump over to so that you jump into that demo. So if anyone's got any questions on the VS Code side of things as well, then feel free to put them into the chat at the moment. But you see we get responses from our server, and if we jump and keep doing our queries and run a few of them, we get more responses in our terminal. And so the resources for these as well will be provided in the description as well. So Dave, if you can share your screen through StreamYards, and I'll get it up live for you. Okay, I think you're muted at the moment as well.
Yeah, so yeah, thanks, Tig. So I've got a couple of demos to show. And the first one is quite similar to Tig's, although I'm using a different framework and I'm using .NET. So I'm using .NET 6 here, and I have my Azure function on the screen. And I'm also using Visual Studio 2022, whereas Tig was in VS Code. So I've done a fairly similar thing where I've created my function locally. This sample, by the way, came from a blog, and we'll share the details for that afterwards so that you can go and look at it. But it's fairly similar in its structure, but it uses a completely different library. And so if I go to my NuGet packages, you can see that I'm using Hot Chocolate, which is a library for GraphQL for .NET. There's also GraphQL.NET, but I thought I'd use this one for the purposes of this demo. And the structure is always the same with any type of GraphQL server, where you'd have your schema definition, and then you would have the queries, mutations, etc. So in here we have the types that we've defined here. We've got a student, school, class, and we have a set of queries or resolvers. And we can do things like fetching schools, fetch schools by ID. We can fetch a student by ID. And all of these resolvers are going off to a backend to go and fetch the data. Now, in this case, it's just an in-memory database, but it could be, as we discussed earlier, another database or set of REST APIs, etc. So I ran this a couple of seconds ago, just in the interest of time, and this is the endpoint running locally. And you can see that, in similar to Tig's demo, we get this rather nice UI that is rendered by Hot Chocolate. So I've got my query here, and I can say that I'm interested in finding a specific student. But I could then go and say, and I get IntelliSense here, and maybe I would like their surname as well. But I'd actually like to know the class that student is in, and I'd like its name. And if I execute that, then we can see now that we get the class name. Now, I can also come down here and say, actually, it's part of class. So if I hit class, I can then say what school as well and hit execute. You can see how, given the the schema definition, which looks like this, ignore this stuff at the top, but here we can see the queries, we can see the types, the student, the class, the school. And these types were created automatically by the Hot Chocolate framework. I didn't have to go and create this schema. It generated it for me based on the definitions that I'd written in my code. So I've got a local GraphQL server running now. It's running in .NET using Hot Chocolate. But I can also, as Tig showed you, I can deploy that into Azure. So if I now switch here, this is the same API deployed as an Azure function, just running in the cloud. And if I click run, then you can see it's coming back with the results that I would expect. And I'm just fetching back some class details here. And like I said, there are various different types of framework that you can use, and just go and take a look at them and figure out the one that meets your need the best. But I've been pretty impressed actually with Hot Chocolate. I think it works really nicely, but GraphQL.NET is great as well. So as Tig mentioned, we can also import these things into API management. So if I click on APIs, we have a whole host of options here. So you can import WSDLs, you can create an API from scratch, WebSockets, etc. So if I want to do a GraphQL, synthetic GraphQL endpoint, where I'm exposing this API through API management to that backend service that I've just defined as an Azure function, I can click on GraphQL, I can give this a name, and I'll call it student graph. Now my endpoint is the endpoint of the Azure function, which will look like this. I can then upload the schema, and this is the schema that I've just downloaded from my from the Azure function that I created, and I'm just going to paste this in here. Here's my schema. And I'm going to give it a name, and I'll call it students. And this is the URL that we'll hit in API management in order to call this API. So if I click create, and it's already in use, so let's call it student graph 2. And student graph 2, the beauty of live demos. So that's one I did earlier. So let's just call that student graph 2. There we go. So there's one there, just in case things go wrong. But here we go. We can see that we have the front end, and what you're seeing on the screen here are the different sections or the different areas of pipeline that the request will go through in API management. And we can apply, as Ty mentioned, policies to do various things as the request flows through API management. But on the front end, we have all of the queries that we defined in our schema. And if I go and click on test, I can see here that we've got the student by ID. I choose student number 1, and if I say I'd like their surname, then hopefully we get the student coming back. And I can do the same kind of thing that I did earlier, where I can click class, I can click name, and then we get those values coming back. So what I could do, given that this is now hosted within API management, is I can go to policies, and there's a whole host of things I can do here. I've got caching available to me. I've got transformation that I can use. I've got rate limiting, so I could prevent certain clients from being able to call my API too often, maybe 10 times a second or 10 times a minute, or whatever I wanted to do. So we have these policies available within API management. But we also spoke about synthetic graph. And here's one I created earlier, but I'll go and do it from scratch again. So if we click synthetic, and we'll call this student synthetic, and we'll say name. I'll go and select the same schema. And then I also need to give it an endpoint where if I don't have a resolver configured in API management, it's going to go here. So this is going to be the default place that it's going to go to. So if I create that, we now have this API. Now this works in a very similar way to the pass-through that I created. So if I go and click test, and I go and select student by ID, and we select student 1, and I select first name, and I click send, then it works as expected. If I go back to design, and I click on the schema, you can see down the end that we have a student, a class, and a school. But what if I wanted to return some additional data about the student? some contact details, and those contact details are defined in a completely different REST API. Now, I could go and change the GraphQL server, but I may not have access to that. That could be managed by a different team. And I would have to go and completely change that code to go and make a call into my REST API. But I could just do that here directly from API management in a matter of seconds. So I can go and define a new type. So let's call that contact details, and there's a bunch of details here. And I can then just go and add a type, or a field rather, against my student. My student now has a field called contact details, which I've defined. So if I click save, and if I go and test this, and I do student by ID, you can now see we've got contact details. So I could think, yeah, I'll have some of that. I'll go and get the house number, and that's failed. And it's failed because there is no resolver for contact details in my backend Graph API. So what I can do in API management is I can go and add a resolver for that specific field. So if we go to policies here, and I created this policy earlier, so I'm just going to go and paste it in here. So if we go to the back end, I'm going to paste so what is this doing? What this is saying is it's configuring a resolver, and I'm specifying the parent type. The parent type is the student as defined in my schema, and the field is called contact details. What I'm going to do is go and issue an HTTP post against this URL, and this here is just syntax for what's called a named value. It's like a variable in API management that contains the actual URL of the backend. I'm going to specify that I'm passing a JSON payload, and here in the body, I'm actually fetching the details of the parent response, which in this case is the student object. So I can reference any field I want to from the student object, and I'm going to get the ID, and I'm going to specify that as a JSON parameter called student ID for my backend API. So if I save that now, and if I go and test it, let's hope that it works. So if I now and go student by ID again, and I will go and choose student 1, and I say I'd like first name and maybe surname, but now I'd like some contact details, and I need the ID as well. If I say I'd like home number, house number, mobile number, and I click send, we get an error. And why is that? The demo gods are not with me today. If I, instead of just trying to figure this out, and I'm sure I'll figure it out in a second, if I just go back to this one, which definitely did work, and if we go to test and we go to student by ID, if I go to student number 1 and I click on first name and contact details, home number and ID, and click send. There we go, that works. So it's a good job I created this one earlier. I don't know what it did wrong with the other one. But you can see now that I'm getting some contact details back, which has come from the REST API that I defined, and I did that by passing in that ID directly from the student object. And so you can create as many of these as you like. So you can we could, for example, go and add another resolver down here at the down at the the class level. There might be some additional information I'd like to pull back here. and I could just go and add that to the type or to the schema definition, and then just go and create that resolver in the policy. And I think that was everything, wasn't it, Tyke, for the API management demos? I'm going to go and debug this now and find out what I did wrong.
Thanks a lot, Dave. So I think, are you able to show us the Logic app as the back end as well, by any chance?
Yeah, it's just here.
Okay.
So this is
bring it up on screen. There we go.
Okay.
Yeah, it's all good.
So yeah, the back end is a Logic app, and all this is doing is receiving a payload, and here's my schema definition. I'm passing in a student ID, which you saw from the resolver, and I've got a really simple set of conditions here, where if it's number 1, I'm returning this payload, and in reality, this would be some kind of database or something like that. And then if it's number 2, I'm going to return this payload. And just to kind of prove that works, if I go and choose number 2 and I hit send, and we get back a different set of details. So yeah, I chose a Logic app to do that work, but it can be anything. It could be some other REST API, or Azure function, or even something that's sat on premises. And with API management, that could even be a SOAP endpoint, because API management is able to do that conversion for you. So incredibly powerful.
Yeah, I completely agree. And it's all down to those resolvers, just setting up different resolvers and combining all these different resolvers together to form what looks like one overall API that a user is engaged with. But actually, there can be loads of things going on in the background, right? You can be combining loads of different systems. And I think that's a great example. And some of the other examples I've seen, even on our Microsoft developer sort of channels on the Azure Friday stuff, is around a SpaceX implementation of GraphQL, where Elizabeth goes and grabs the image of one of the rockets, and she does that with a Logic app using blob storage. And that's a way of extending the value of the API that she had for that scenario. So yeah, thank you very much for showing us that demo. And we've actually got some time for some questions. So Asta, I've brought you up on screen. Is there any questions that you want to highlight from the chat?
Yeah, so fantastic job, guys. I'll just bring up some of the questions. So someone's asking, I'm looking for advice on how to architect a query endpoint over a relational SQL server, how to keep the document DB hacking the GraphQL updated when the SQL tables are updated.
Dave, do you want to have an initial stab at this one?
Yeah, I mean, I guess at the end of the day, the schema that you've defined for your GraphQL endpoint is what the client is going to be bound to, and if the back end is changing, then clearly you've got a dependency there, and it as we discussed earlier on, the important thing is to make sure that you're not breaking your clients when the back end changes. I mean, I don't think there's a really straightforward way of dealing with this, especially if you're changing the back end in a way that's going to break the schema or break the operations for the data that's being returned. But we could pick this up offline to talk about it in more detail to understand the scenario a bit better.
Yeah, and I think I guess it leads to a point around GraphQL and the value of it around schema changing and things like that. So if you are utilizing a GraphQL API and you're specifying, and say they make a change and they add loads of more data about that API, if you're just requesting, like Dave was requesting, like the name and the class, but say loads of other things were added, like exam results and stuff like that, that might actually bloat your API response. Then with GraphQL, you're not having to request those extra bits of data. If you're using a REST API in those scenarios where you've got a schema that's changed, that server is sending back everything. They're sending back the exam results, report cards, things like that. They're adding more data than you ideally might want. So GraphQL handles better with some schema changing that can happen, but do with this, Bob, would be around also look at the resolver that you've got configured and how you're interacting with your database from that side, depending on what language you're using and things like that.
Just before we move on to the next question, there was one other point that we forgot to mention earlier on, which is around the depth of those queries and how complex they can appear on the back end. One thing that API management does have, which I could demo if we've got time, but I think we're almost out, but you can actually validate the GraphQL request that comes in. So you can specify there a maximum size for the request, but also the depth. So you can make sure that the query isn't going too deep into that schema that would generate something really quite complex.
I think that probably links to this question, Asta. Is this one of the next ones that you had?
Yeah, it was. So just to say out loud, any tips to make sure that the GraphQL endpoint doesn't generate queries that makes the database go into slow mode because of the query complexity?
Yeah, and I think it's a couple of things. It's the complexity of the schema to begin with. So if you've got something really, really complex with lots of relationships, then if you're and these frameworks can go and they can generate SQL, that could get incredibly complex. So that's directly related to the complexity of the schema. But also, I think with like the validation that we just spoke about, is making sure that that GraphQL server is not accepting these kind of requests that are going to go and generate some kind of hideous query on the back end that's going to make it just be really slow or have lots of blocks, etc., that are going to really hurt scalability. So yeah, you do have to be really, really careful there.
We've probably got time for one more question, Esther.
Yep. So another question is, how would you typically run operations like process invoice from GraphQL?
Yeah, I don't think I would. I think there are cases where GraphQL is the right choice, and there are cases where a REST API is the right choice. So an operation like process invoice to me feels like some kind of business process that you want to kick off. In which case, that would suit really well as a REST API. If, however, that process or that process invoice, it might be touching lots of other data on the back end, multiple databases, etc. And there's probably some client there somewhere that wants to go and understand where their invoice is at or where their delivery is at, or whatever it is. In which case, GraphQL would suit really well, because that is then allowing that client application to go and pull back the various bits of information that would allow it to render the status of that order on the screen. So I don't think there's a one size fits all here. I think you have to choose the right technology for the right use case.
Brilliant. Well, thank you so much. Thanks, Asta, for asking those questions. Thanks, everyone, for putting those into the chat. Massive thank you, Dave, as well, for doing the presentation and doing those demos. So we're going to pretty much wrap up now. We're going to jump on to the last few slides, but I'm just going to send you to the background, Dave. So thank you so much. Okay, developer news radar, the last couple of things to touch on. There's two things that I wanted to highlight around developer news at the moment, and that there's been a lot of progress with static web apps. So there's .NET 7 support and Node 18 support that's come to that. And then also wanted to make people aware on the Logic Apps side of things. So if people have been working with Logic Apps ISE, then this will be deprecated in August 2024. So there's been a new migrator tool that's been recently published from the Logic Apps team. And so I want to point people towards that tool and get yourself familiar if you're working with Logic Apps ISE, the integration service environment. So a couple more things. If you're already working with us, then please do contact your account teams to get engaged with things like open hacks or cloud skills challenges. So if you want to pursue your learning a bit more, then these are great ways to do that. And if you have any questions about that, please feel free to reach out to us at lunchbytes@microsoft.com. And also check out the UK Developer Hub. So this is at aka.ms/UK Developer. You can find loads of trainings that are available there. And then also there's loads of communities that deliver technical sessions, just like the one that we did today, but for more local scenarios. So we've got loads of communities across the UK, ranging from Azure Yorkshire down to Azure Thames Valley. And so visit aka.ms/UK developer community to get a list of those communities that you can go join and get engaged with. So it's great, really fun sessions that some people do there. And then finally, check out our playlist on YouTube. So if you enjoyed today's session or you want to cover some of the other topics that we've done on LunchBytes, then visit aka.ms/LunchBytes. And that will take you to our YouTube playlist where you can see all 15, 16 episodes of LunchBytes at the moment. And Asta, do you want to finish us off for today?
Yeah, of course. So coming up in 2 weeks, we have another really exciting session where Prakash Bigala will be having a presentation on message transformation and mapping options in Azure. So again, same time in 2 weeks, which is going to be really exciting.
Great. Thanks a lot, everyone. See you soon.